behind the camera, and this is our senior design project. It's a chessboard that moves the pieces automatically. We're controlling it with two stepper motors. There's one right here and there's one right here, not very visible. The electromagnet is right here. It's pretty big. It's powered by 12 volts. We're controlling everything with a Atmega 324P microcontroller. It's down there, and we can actually control the pieces on the laptop right here through a USB cable. And that is the chess program right there. We used a open source chess program, and we modified it in C# to send serial signals to the Atmega 324P. This is a kind of modified, what's it called?
CNC?
Oh yeah, CNC machine. We're using an ATX power supply with a resistor right here. This thing gets up to 400 degrees, and it's burned us many a time.
That thing right there.
I have the scars to show it.
That's why it's in the back, out of the way.
Alright, the first thing that we do, since we don't have any way of detecting the electromagnet's position, is we have two limit switches, one right here and one right here, and it resets the X and Y position when we initialize. That is initialization. Now we can make any move that we want to make. If you look over here, we're going to move this knight to right here. And now you can follow it on the now it's black's turn. I'll just keep making a bunch of moves now.
These are bipolar stepper motors. 48 steps per revolution.
Alright, now we're going to do a capture with the knight.
The chess piece goes right next to the soon-to-be captured piece. De-energizes the magnet, picks up the piece, energizes it. It has to slide on the line just to make sure that there's nothing in the path. De-energizes, offsets, and then repels the piece into the capture zone, and then finishes the original move.
Let's have the queen take the knight now. Actually, white has to move first. Pawn takes the knight, or pawn takes the queen.
Since it's already at an adjacent square, it doesn't need to move. Then escorts the queen to the capture zone. Watch the offset, reverse polarity. Oh, yeah. And then it's going to finish the original move. These are about 21-inch long lead screws. Remember the pitch on them?
Half an inch linear motion every revolution.
We've got
It's the lead at least.
bearings. Stepper motors are being driven by full dual H bridges. In the driving logic, the 297 and the 298 by ST. This electromagnet runs off 12 volts, about 240 milliamps. That goes through a full bridge, which lets us reverse polarity